In this video, another solution for an epicyclic train problem will be demonstrated. This is the same mechanism as in the first problem, but with different conditions. The arm rotates 3 times in the counterclockwise direction, while gear 2 is stationary, and the problem asks for the rotation of gears 3 and 4. We can look at the actual mechanism. The mechanism rotates 3 times in the counterclockwise direction, with gear 2 stationary. By the formula method, if gear 3 is the last gear and gear 2 as the first gear, we have this as the number of rotation of gear 3. Using the formula method again, with gear 4 as the last gear and gear 2 as the first gear, we will have this as the number of rotation of gear 4. We can now proceed with the tabulation method. First, we will have a table. This table, and with this as our mechanism, we will have this as the column for the arm. This is the column for gear 2, for gear 3, and gear 4. Our 3 steps include that of locking the arm with the gears and rotating the whole mechanism. Second step involves that of holding the arm stationary and rotating the gears, and the third step is that of finding the resultant. We do remember that these two values, -3 for the arm and 0 for the gear, are given, and we have to determine the gear 3 and gear 4 rotation. We can proceed with our first step. As we put -3 in these boxes, we can see that the actual mechanism is rotating 3 times in the counterclockwise direction as one body, including that of including gear 2. So we can put -3 in these boxes. As our second step, we will have to fix the arm. That is, writing 0 in the box of the arm. And we understand that the addition of these numbers in the column for the arm will result to -3 for the resultant. That is also true for gear 2. We put +3. If we add it to -3, that will be 0, which are our given, one of the given. We can see the actual mechanism. The second step involves that of rotating the gear 2 in the clockwise direction 3 times. With this, we can proceed in filling up the other 2 boxes in the gear for gear 3 and gear 4. As our third step, we can add the values for each column and obtain the solutions. We now have the number of rotation of gear 3 and the number of rotation of gear 4. We can actually verify the solutions. We have the mechanism in this figure. For gear 3, this is the original position and the final position. And we have this negative 6.375 as the rotation of our gear 3. For gear 4, this is the original position and the final position after 2.4 rotation of gear 4. Looking at our video again in a slow motion, we can actually verify the actual number of rotation of each gear. This is the second rotation of the mechanism. And this is the third rotation of the mechanism. Now we can see the diagram again. For gear 3, we have 6.375 rotation in the counterclockwise direction. And for gear 4, we have 2.4 rotations in the clockwise direction. This verify our solutions earlier presented. There will be more sample problems in the future. If you have any particular problem you wish me to solve, you can send it to me. I'll try and perhaps upload the solution in YouTube. Thank you very much.